About 75% of angiosperm species are pollinated by biotic vectors. Biotic pollination is considered as a classical mutualistic interaction between the plants and pollinators. In exchange for pollination service, the plant provides food for the pollinator and sometimes shelter or even nursery for their offspring. All kinds of animals can be pollinators. You already know about the classical ones: bees, butterflies, moths, flies, and wasps. But some plants are pollinated by herbivorous bats or birds. Some beetle species are also pollinators, as well as ants. We even have small mammals, such as these lemurs or lizards, that can act as pollinators. Here is a video of a gecko lizard that feeds off the nectar of a flower.
When drinking the nectar, the lizards dive into the flowers and crawl over them. All the time, pollen dust is brushing off onto their bodies.
We already established how plants benefit from their interaction with pollinators. They get pollinated, which directly increases the fitness of a plant. But what's in it for the pollinators? Most often, the pollinators get food from the plant. This can be pollen, nectar, but also protein or lipids. These two Onysidium orchids have epidermal elaiophores that secrete lipids directly on the surface of the petals, hence their glossy look, as well as Chromaria capsudata that has structures called elaiophores, which provide lipids as a pollinator reward. Other plants do not provide any reward for pollination, but instead they give shelter to insects or their larvae. This iris is the largest Mediterranean flower. It does not have nectar, and its pollen is hidden at the bottom of the elongated corolla. Its dark corolla absorbs a lot of sunlight during the day, and the flower offers a shelter that is a couple of degrees Celsius warmer than any other flowers. The solitary bees that spend the night in this flower have higher body temperatures early in the morning and can emerge earlier to start harvesting pollen and thus beat the competition. All fig species are pollinated by wasps in a very unusual way. The wasp uses the fig as mating ground and site for laying its eggs. So a wasp would enter the fig, lay its eggs, and then die. When the eggs hatch, they will exit the fig mate, and then the pregnant wasps will enter a new fig where they would deposit the eggs. During this entering and exiting of the flowers, the wasp collects pollen on their body as they exit the fig flower, and then they deposit it on the stigma when re-entering a fig to lay their eggs. But not all plants are offering rewards to their pollinators. Some have evolved to cheat the pollinators for their services. For instance, many orchids imitate the shape, color, and most importantly, the pheromones of their pollinators, so that confused young pollinators would try to mate with them. During this pointless mating trial, the pollinator gets covered with pollen, which it can then carry to other species. This strategy relies on the experience of the pollinators. Young, naive males that have not yet learned how to recognize an actual mating partner will more likely be cheated by the mimicking orchids. But as time passes by and the pollinators learn how to reliably recognize a real mating partner, they will start visiting the deceitful orchids less and less often. Other plants falsely advertise themselves as rewarding in nectar. Many ranunculus species, for instance, bear these erect, glossy structures called pseudonectaries. They look like they offer sugary, glossy nectar to the pollinators, but in reality they offer nothing. And finally, some plants mimic suitable shelters for their pollinators or pollinators' larvae. This is the case of the giant corpse flower, which got its vernacular name because of its notoriously infamous smell of rotten flesh. The smell attracts flies that lay their larvae on the flower, and in the process carry or deposit pollen from one flower to the other. However, because the flower is not actually a rotten corpse, the larvae will soon die after hatching because they have no food. But plants are not the only ones to cheat in their interaction with the insects. Insects can cheat as well and rob the plants of their reward without actually pollinating them. To the plant-pollinator interactions, although they're often cited as mutualisms, range a full spectrum of interactions that can be exclusively beneficial for the pollinators, to mutually beneficial for both parties, to exclusively beneficial for the plant. At the extreme benefit for pollinators only, we have theft, pollinators that pierce the flowers to collect the reward, but no pollination occurs. Then we have pollinators with low pollination efficiency, where the pollinator hovers over the flowers, rarely getting in contact with anthers and stigma. We also have balanced pollination mutualism. We have special structures which optimize reward for pollinators and contact of the pollinators with the flower. Then follows strategies that have more advantage for the plant than for the insect. First, pollination with little reward, when the pollen is not nutritious enough or there are not enough quantities of it. This usually works when there are no alternative resources for pollinators. Follows pollination by trapping, where the plant traps the pollinator for a prolonged amount of time to make sure that it gets completely covered with pollen. Then there are pollinations with toxic rewards, which sometimes can render the pollinators dependent on these flowers so that they would stop seeking for alternative food resources. And finally, there is pollination through deception, which depends on the inexperience of the pollinators and their flower constancy.